Okay, for question 6, actually this question is another question that we lifted out from your subject day practice paper. Later I will show you side by side how the questions are the same, but yet many of you are unable to take advantage of this situation. And of course, it is time for you to reflect why is it that during exam condition you are unable to perform, right? So for 6A, I think most of you get the full mark. We just want to find out whether you understand what we mean by at the molecular level, which many of you did. So basically the warmer water in the swimming pool, the warmer water in the beaker will have molecule that is moving faster, and because both water in swimming pool and in beaker, they are the same state, even with a higher temperature in the beaker, the average separation distance between the molecule is just differ by a little bit. So initially we feel that the word slightly is important, but later during benchmarking we decided to make it more relaxed. So remember, although there's a small difference in separation distance when temperature is higher, but if they are in the same state, actually that difference is very, very little. Yeah. Okay, for part B, this is the one where we feel most disappointed as teachers because it is a question that is lifted out. So now I will show you side by side how similar are they. So in this question, they are asking you about which water has greater total internal energy. I just want to emphasize on this total, right? And I just want to emphasize on the context. Swimming pool, cooler, beaker, warmer. But swimming pool, big. It has a high mass of water. But in the beaker, it is 200 cm cube. It is small. It is having very low mass. So far, okay? Now, if you go to your subject day 4, okay, subject day 4, question 19, you will see this question. Swimming pool, cool. Kettle, a smaller volume, hot. So, swimming pool, big, high mass. Kettle, hot, but small, low mass. Now you see the similar context. Let's look at the question. Between the kettle and the swimming pool in the subject day, which one has greater total internal energy and which one has greater average kinetic energy? So they are checking whether you can tell the difference between total and average. Do you understand the implication? And we feel that this question is important. That's why we put it in the subject day 4. And we want to use the prelim to check whether you understand. So what does the result show us? The result show that maybe during lesson you can recall the difference, but you lack the deep understanding. That's why when the same question pops out, many of you make the same mistake that you made during your subject day 4. Well, what is the implication? The implication that we want students to see is that if you are in a swimming pool, the volume, the mass of water in a swimming pool is very, very high. And because the volume is very, very high, in the swimming pool, there is going to be a lot more molecules in it. And each of these molecules carries internal energy, right? It carries kinetic energy, it carries potential energy. So even though there is a temperature difference, the IKE, of course, if we only look at the IKE, the beaker will win, right? The beaker will have definitely a higher IKE. But if we look at the total internal energy, which consists of your IKE and your IPE, Yes, I would say that the beaker here would have way more IKE than the swimming pool. But even though the beaker's molecule are able to move faster, but the swimming pool has more molecule. So if you think about this, swimming pool versus the beaker. Okay? Swimming pool versus the beaker. Swimming pool is cold. Beaker is hot. Correct or not? So let's say because it is cold, the kinetic energy, sorry, I shouldn't use IKE, kinetic energy of molecule, let's say 20 joules per one molecule. Beaker, because it is hot, let's say 50 joules per one molecule. But the swimming pool has a lot more molecule, right? So let's say the swimming pool has maybe 10,000 molecule. Okay, because the beaker is way smaller compared to the swimming pool. Maybe the beaker has maybe 500 molecule in it, let's say. Right? So what is the total kinetic energy of molecule? Down here, it will be 20 times 10,000, which is about 200,000 joules. Down here will be 50 joules multiplied by 500. It will give you about 25,000 joule. How about potential energy, the IPE, the potential energy of molecule? Both are liquid state. Let's say they are 30 joules per molecule. This one may be 30.0001. Let's make it the same because they are both in the same state. Again, I will have 30 times 10,000. On the bigger side, it will be 30 times 500. This will give me about this. This will give me about this. So, total internal energy, it will be this plus this versus this plus this. Which one higher? Obviously, it's going to be the swimming pool. So, because of this, the total internal energy, the swimming pool will be higher because it has significantly more molecules in it, even though on average, right? On average, what do I mean by on average? On average, if we are looking at per one molecule, the beaker will be higher because it's warmer. But if we look at the total, then the swimming pool will be higher. So because of that, what you have in mind, which many of you have, you are looking at the average, meaning that you are not very sensitive to the word that we use, whether it is average or total. So if you look at your subject day 4, you can see that this MCQ is trying to check whether you have this understanding, that in the total, the pool will have higher because it has way more molecule. But if we are looking at average, which is the meaning of per one molecule, then the kettle will be correct, which you can see. You can see or not? Get right the answer one. So for my class, I know that we have gone through this because it is highlighted. Yeah? So we need to reflect, why are you getting it wrong? Why is it that you forget? Is it lack of preparation? Not enough time to prepare, or that you are too stressed that you cannot relate? Okay? Okay, for the last question, is about how to describe evaporation and explain that it has a cooling effect. Like I said many times, evaporation doesn't absorb energy. And in the earlier videos, I always said, teachers will always embed misdirection to see whether you have real understanding. The misdirection that I embedded here is, I purposely give you a higher temperature to guide you to use the word gain energy, because if you look at the question, the swimming pool is 25 degree. So, well, it is gaining energy. But if you look at the evaporation process, in class we keep telling you, I don't want to see this word gain energy, because evaporation doesn't need to. What do you mean by doesn't need to? Let's say the temperature outside is 10 degrees C, and you will have a puddle of water that is, say, 30 degrees C. Does evaporation occur? Yes, it does. Does this water gain energy? No, it doesn't, right? Hot, cold. Your heat will transfer out. You will have heat loss. Does evaporation happen? Yeah, it does. It does. So, I don't want to see the word gain energy whenever you are explaining how evaporation occurs. What I want to see is that just use this word. The more energetic molecule at the surface, because evaporation is a surface phenomenon, right? Do I need to say break the bond, enter the atmosphere and all that? No need, because it's 2 mark with 3 lines. Just tell me that they are gone. They are out of the system. So as a result, the average IKE of the water would drop. And average IKE relates to the temperature. So you have explained why is there a cooling effect. Okay, so this answer gives you like the bare minimum that you need, right? Anyway, it's just 3 lines, 2 marks. So I don't expect a full elaboration of the whole process. Okay, so I hope with this video, you now have a better understanding on what is the difference between, or what is the implication when we say total internal energy versus average. Okay?